Okay, so let's start chapter 2, sampling, standardization, and calibration. Okay, so this chapter focuses lang on the conduct of sampling, how standardization is done, and how do we calibrate stuff sa Anachem. How do we calibrate measurements in Anachem? So this is just kwento. So wala tayong solving dito. Okay, so let's talk about sampling. Okay, so when we say sampling, we are actually obtaining a portion of your population. No? So kukuha ka ng onting bahagi ng population. Di ba yun yung meaning sa stats ng sampling? In analytical chemistry, what we are pertaining to sampling is yung kukuha ka ng small amount ng substance from your original source, no? Okay, so that's what we call sampling. Okay, so kunwari mag-analyze ka ng water, let's say Pasig River, you do not need to analyze the entire river, 'di ba? Di naman ganun ka ridiculous yung testing, 'di ba? So gagawin mo, you will just get a portion of the water, let's say 1 liter out of the entire volume of your river. Okay, so yun yung sampling. Kuha ka lang ng portion from your population or your original source. Okay, and alam natin that after we get the samples, we process the samples and we analyze the samples, di ba? If you could still recall the graph sa chapter 0, after obtaining your sample, ano sunod? Process the sample, analyze the sample, then measure your results, di ba? So, depende kasi sa type ng ina-analyze mo. So, depende sa amount of matter that you are looking for in your sample. There are several types of analysis that can be done. No? So, may analysis na super sensitive. There are analysis na hindi masyadong sensitive. Okay? So, again, ano yung kwento natin dito? Depende sa amount ng matter na hinahanap mo, yung process mo. Okay? So that means if you have samples greater than zero point 0.1 grams, then that's called macro analysis, no? So you can do the usual classical methods sa Anachem dyan. You can use titration, you can use gravimetry, no? So that's my macro analysis. Okay. So again, kapag malaki yung sample mo, let's say greater than zero point 0.1 grams, that's called a macro analysis. However, if your sample, no, if the amount of your sample ranges from 0.01 to 1 gram, then that's called a semi-micro analysis. Okay, and then further below the line, no? So, kunwari, if you are analyzing samples of 10 to the negative 4 to 10 raised to negative 2, then that's called micro analysis. And then anything less than 10 raised to negative 4 is ultra micro analysis. Okay. So, ano yung purpose nitong different types of analysis? Sabi ko nga kanina is that for every type of analysis, you have to have certain processes, no? Certain analytical method that can be done. Okay? So for example, you are doing ultra micro analysis, no? Hindi na pwede dyan yung titration because if you titrate your sample against a standard, no, hindi mo na mababasa yung amount ng matter na yan because look, that's 10 raised to negative 4. That's at least 0.01 milligram, no? So, hindi na niya kaya yon. Okay, so that means for every type of analysis, there are specific analytical methods that can be done, no? Kasi sometimes your analysis needs um, much precise instruments, no? Mas sensitive na instrument ang kailangan. Okay. So, yun yung first goal nyo. Once you have your sample, identify if asan siya dito. Okay. So, for example, I gave you 3 grams of the sample. then obviously you can do macro analysis, no, or the classical techniques, no. Pwede ka mag-titration, pwede ka mag-gravimetry dyan. However, as long as your sample size decreases, no, pag mas lalong umuunti yung amount ng substance na i-analyze mo, you have to use special techniques, no. So, pwede ka na mag-electroanalytical methods, pwede rin spectrophotometric, no. So, ganun lang. For example, drug testing. Asan kaya yan? So, depende, no? So, it could range around dito sa microanalysis, no? Because we are just observing a very tiny amount of molecule in your sample. Let's say blood, di ba? So, hindi naman naabot ng 0.1 grams yung drugs doon, for sure. Patay na yung taong yun siguro pag ganun. So, most likely, it will range around this microanalysis part, no? So, that means you have to use the appropriate technique or the appropriate instrument or method, no? When analyzing methamphetamine hydrochloride against your sample. So, yun yung drug testing. So, alamin mo, gaano ba kalaki yung ine-expect mo dito. Okay. So, after alam nyo kung gaano kaonte yung ine-expect nyo dito, you can do your microanalysis na. No? So, ganun kasi sa sa analytical chemistry. Kumbaga, we have a cookbook, no? Nakwento ko na ata yung dati. So, yung cookbook na yon, that is a book, no? Composed of analytical methods, no? And depende sa amounts ng sample nyo, there is a specific procedure for that. Specific instruments that needs to be used, no? Etc. So, ganun yung ginagawa namin sa Anakim. Okay, so again, you have to infer your amount of your sample first so you can do the proper analytical method. Because if you did not use the proper analytical method, then pwedeng magkamali ka sa readings. Okay, okay, and that may destroy the reputation of your laboratory. Okay, so yan. Also, depending on the amount of your, kunwari, depende sa amount ng inyong ina-analyze na matter sa inyong sample, we can classify them as whether they are major, minor trace, or ultra trace constituent. No? So, ibig sabihin kapag major constituent, so that means it comprises most of your sample. No? Okay? Pero as the concentration of your solute, no, or of your solute sa inyong solution or your sample, as the concentration decreases, then it becomes lower sa classification ng as cos ano yun? Nabulol lang ako. Kapag umuunti na yung concentration ng inyong sample, yung concentration ng solute sa inyong sample, kapag umuunti na yung amounts niya, then nagbabago na yung classification niya. No? So, it could be major constituent if the concentration is around 1 to 100% of your sample. However, if you go down the line, pwede siya maging minor constituent, trace, or ultra trace. No? So, wala naman masyadong kwento dito. So, ang ganap lang dito is yung result. Depende sa percentage na makuha mo. You can tell if that's a major, minor, trace, or ultra trace constituent of your sample. Okay. So, kumbaga, ito ay after the analysis na. So, ganun ginagawa. Let's say, kunwari sa water, you have found na meron kang less than a milligram of mercury in your sample. Okay. So if you have anything less than a milligram, then we can tell that yun ay minor constituent ng inyong substance. Okay. So ganun. Kunwari, you have 90% alcohol. Now, you have 90% ethanol in your sample. Then you can tell that is a major constituent of your sample. No? So, ibig sabihin, depending on the fraction ng kanyang, depende sa fraction ng sample mo, yung solute, then may kanya-kanyang classification for that. Okay. So again, 90% ethanol, it will fall under the major constituent category. Pero kapag umuunti na yung concentration niya, let's say 30 ppm bicarbonate, no? So kapag 30 ppm bicarbonate, then pwede na siya dito sa trace, no? Okay, so pwede na siya sa trace, no? Within that range na. Okay. So kunwari, mercury sa blood, no? So that's around parts per billion na. So kapag parts per billion, ano na, yung concentration ng inyong solute sa inyong sample, then we can call it ultra-trace constituent, no? Ibig sabihin super onti na ng amount ng substance na yon sa inyong sample. Okay? Okay. And also, when we do chemical analysis, di ba nag-sample tayo? Ibig sabihin, kumuha tayo ng 1 liter from the Pasig River or 1 liter from your ano, water, ang tawag doon, water faucet, no? So, kunwari, kumuha ka ng 1 liter doon, hindi naman lahat ng 1 liter na yon i-analyze nyo, no? Hindi yun lahat i-analyze, hindi yun lahat ita-titrate, no? Hindi yun lahat ilalagay sa gas chrome, etc., no? So, ganun din naman sa blood testing. Di ba, kukuha ka ng vial, let's say, mga ganito kalaking vial ng blood. Hindi naman lahat yun i-analyze nyo, no? So, you will only get a small portion or a few milliliters of your sample. Yun yung ina-analyze nyo, okay? So, kumbaga, ang tawag doon ay representative ng inyong sample. Okay? So, yun yung ginagawa. Again, kapag kumuha ka ng 1 liter solution, let's say sa ilog, hindi lahat yun ina-analyze. We'll only get few amounts from that sample. No? Yan. Kukuha ka lang ng few amounts doon sa inyong sample. Okay? So, we call that the representative. No? Kasi kung ano yung measurement mo for that few amount of sample, that must be true for the entire sample and the and the entire population. It must represent the total amounts of solute in your solution. No? Kasi homogeneous, di ba, ang solution. So that means kung ano yung concentration sa few ml ng sample nyo, that must be the same concentration sa 1 liter ng kinuha nyo, and that means the concentration must also be the same doon sa original source nyo. Let's say sa Pasig River. Okay, so during my undergraduate, no? So, nung college ako, ganito yung ginagawa namin, no? So, doon sa Pasig River, we ride the ferry. Then, every station, kumukuha kami ng water sample. Then, what we do is that, kukuha kami ng 1 liter solution. Okay, so, meron kaming bucket. Lulublob namin yung sa gitna ng Ilog Pasig. Okay, buti na lang mabait yung mga nag-aano ng ferry doon. So, ilulublob namin yun sa Ilog Pasig. And then, ilalagay namin siya sa special container. Then, pagdating sa laboratory, yung 1 liter water na kinuha namin, we will only get at least 10 ml of that solution. Okay, tapos yun lang yung ina-analyze namin. Then, kung ano yung na-analyze namin doon sa 10 ml solution na yun, we generalized it, no? So kung ano yung nakuha naming concentration sa 10 ml, ibig sabihin yun na yung concentration for that Pasig River sample. Okay? So yun na yung entire concentration niya throughout the Pasig River. So pwedeng ganun. We call that representative fraction ng inyong samples. Okay? So the usual process when doing sampling is that you identify your population, then you collect the gross sample, and then you reduce it to laboratory samples. No? So ito yung typical stats. No? For example, sa survey, kunwari magsa-survey kayo, hindi mo naman isa-survey lahat ng tao, di ba? Okay, so for example, ayoko gamitin yung Pulse Asia kasi alam nyo naman, Ano pa ba bukod sa Pulse Asia? Wala na akong maisip na matinong survey sa Pinas. Sa ibang bansa na lang, 'no. So kunwari they are doing survey on this market product, 'no. Kunwari sa alcohol, okay ba sila sa alcohol na 'to or not, 'no? So if they are doing survey, hindi naman nila i-interviewin lahat ng tao na pumapasok sa supermarket, okay? They will only handpick few number of people. Okay, so kunwari out of 10,000 na pumapasok sa market every month, they will only interview 50 of them. Okay, so yun yung pagkuha ng sample. So may equation for that. I think that's Slovin formula. If tama yung pagka-recall ko ng statistics ko. Okay, so yun, using that formula, Slovin formula ata yun, no? So they will get the actual number of population that is a representative to the entire population. Gamitin na natin yung, let's say, Pulse Asia. Although I do not agree with them at most, no. So kunwari sasabihin nila, 'di ba, for the entire population of the Philippines, 'di ba, 100 million, 1,000 plus lang ini-interview nila. Why? Because of this Slovin formula. Okay? So, yun kasi, hindi mo naman kailangan interviewin lahat, no? You will just only get few amounts of that people. So, yun yung gross sample natin. Okay? So, you identify the population, 100 million, then use the formula to identify kung anong sample yung kailangan mo lang, no? And that will be the representative of the entire population. Ang problem lang doon is if may bias, which is true naman, 'di ba? Okay. So, sa chemistry, medyo ganito rin yung ganap natin, no? So, your population is your sample, no? Let's say yung population ko, Ilog Pasig, no? So, hindi naman yung entire Ilog Pasig nga yung i-analyze ko, no? So, I will just get some few amounts of Ilog Pasig, no? So, I will collect my gross sample, that's 1 liter water, and then I will reduce that to what's workable in the laboratory, no? Sa laboratory, 1 liter is too much, no? So, sobra-sobra na yon because in chemistry, we only deal with few ml of your samples, no? Okay. So as you decrease your samples amount, no? Habang napapansin niyo, 'di ba? Every step parang umuunti ng umuunti yung dami ng sample natin. Yes. Kasi onti lang talaga yung i-analyze natin. Dito nagiging important yung pag-homogenize ng inyong solution. So that means every time you reduce your amount of the sample, you have to mix them thoroughly so that they will be homogenized, no? Okay, so that means your solutes will be evenly distributed um, to your solution. Okay, so ganun. Yun yung importance ng homogenation sa sa sampling. Okay, so ganun lang. Again, if you are doing testing, hindi mo kukunin lahat na. You will just draw few amounts, no? And then, papauntiin mo pa yan. Okay? So, let's say drug testing, hindi mo naman kukunin lahat ng dugo ng tao, namatay pa yan, di ba? Konti lang. Then, yung onting sample na yon, kukuha ka lang ng onting part din doon. Okay? So, yun yung process sa sampling. Okay? Ang goal naman is yung magkaroon ka ng workable amount, no, na kaya sa laboratory. Okay? So, ganun. Okay? So, the next part is that ano gagawin mo sa sample mo? Siyempre, you will analyze it, no? And when analyzing it, you have to do standardization and calibration. Okay? So, when you say standardization and calibration, kasi magkadugtong yung mga terms na yan. Ano yung calibration, no? So, ibig sabihin nun is that yung may reference ka, may reference equation ka that tells you the instrument response over the concentration of your sample, no? Kunwari, you are doing copper analysis. So, this one is copper analysis, na. So, for each volumetric flask, there is a certain concentration of copper here, no? Nare dito, 0 molar copper. Nare dito, 0.5. Ano ba yung nakalagay sa graph? Okay. So, kunwari, ito, 0.00175 molar. This one is 0.003 molar, etc. No? So, you have your standard, no? Ito yung pagbabasihan mo ng response ng instrument sa sample mo. Okay? So, kumbaga, before you analyze your sample, you have to have your calibration first. Okay? So, ano yung calibration? Ito yon. You have different sets of standard. Okay? Yung standard, ito yung known concentration. Okay? So, alam mo yung concentration ng mga substance na to. And then, you will analyze it using the same instrument na gagamitin mo sa inyong sample. And then, pag inanalyze mo yan, syempre may instrument response yan. For example, itong nasa y-axis natin. Okay? So, for this sample, let's say, for this standard, let's say, ito yung response ng instrument. 0 kasi tubig lang yan. For this sample, let's say, ito yung response ng instrument. For this sample, let's say, we have this response of the instrument, and so on and so forth. Okay? So, kumbaga, at different known concentration, aka standard, okay? So, again, tawag dito ay standard. Ano uli yun? Known concentration, yung amount ng matter dito. Okay. So, gagawin mo dyan, you will get the instrument response. Kunin mo yung instrument response, and then you will check for the equation of the line that is created by the instrument response versus the concentration. Kumbaga, kung naalala nyo pa yung regression analysis nyo noong senior high, ito na yon. Ito yung application niya sa chemistry. So, ano gagawin nyo? You will have your known concentrations, and then you will analyze it using the instrument. So, it will give a certain instrument response, and then you will do regression analysis. Okay? So, the best kapag ang curve mo ay may R square, ibig sabihin may Pearson correlation coefficient that is approaching to 1, then your calibration is good, no, for your analysis. Okay? So, ganun po ginagawa. Again, ano uli ginagawa? You have your standards, you read the instrument response sa standard mo na yon. And then from those data, you do regression analysis. Okay. So after doing the regression analysis, then you can solve for the sample na. Kunwari, I have this solution from faucet, no? Sa faucet. Hahanapin ko kung ano yung instrument response dito ng sample ko. 'Di ba? Ito yung inyong calibration. Kunwari, kapag binasa ko na yung sample ko, ito yung response ng ito yung response ng sample ko. Paano ko malalaman yung concentration niyan? Eh di hanapin mo lang yung corresponding x-axis para doon. Okay? So kunwari, nag-run na naman ako ng isa pang analysis, tas nung natapos yung analysis, ito yung binigay ng instrument sa akin na na response. Kunwari, andun yung response niya sa 0.20. What is the corresponding concentration of copper? Extrapolate mo lang yung data using statistics. Hanapin mo lang yung value ng X. So, ganito yung ginagawa sa Anachem Lab. So, you do your calibration, and then after that, you read you read the sample, no? So, when you say you read the sample, ibig sabihin nun, you will analyze the sample. Okay? And then you will compare the result with the standard calibration. Okay? So, ito yung calibration, ito yung sample result mo, i-compare mo siya dito sa line. Okay? So, kapag andito yung result, that means ito yung concentration niya. Pag andun yung result, that means andun yung concentration niya. Okay? Kunwari, andito yung result. So, that means the concentration is somewhere here. No? That can be solved using y equals mx plus b lang. Okay? So, you solve for the x. No? So, ganito yung ginagawa sa chemistry. Actually, we can do this, no? Pwede tayong mag-solve, although hindi na namin siya i-cover. Why? Because masyado na siyang calculation intensive. So, kunin na lang natin yung ideas, no? So, ano yung general idea dito? When doing analysis ng inyong samples, first, you have to have your calibration. So, this one is the calibration or the standard calibration. So, anong gagawin mo sa standard calibration? Magsa-set up ka ng different concentration and you will check what is the instrument response for that corresponding concentration. So, ito yung mga black circles na yon. Then, you will check for the linearity using linear regression. Okay? So, after checking the linearity using linear regression, if the Pearson correlation coefficient is approaching to 1, then good yan. Okay. Okay, so yun yung gusto natin. Gusto natin linear yung response ng instrument sa concentration mo. Okay? Then, ano susunod na gagawin? After you do your calibration, i-analyze mo na yung sample mo. Okay? So, kukunin mo yung sample mo, you will analyze it using the same instrument, and then, kunwari, ito na yung result. You will compare your result with the standard calibration. So, itong linear graph natin. So, compare mo yan dyan, and then you will solve for the concentration. You will solve for X. So, that's the usual method that we do. Okay? So, that's calibration. And maraming uri ng calibration. Okay, so tignan natin mamaya. So, number one type of the calibration is called the external standard calibration. Okay, so ito yon. Ito yung diniscuss natin na to. So, when we say external standard calibration, you are establishing the instrument calibration function. Ibig sabihin, inaalam mo yung response ng instrument using external solutions, no? So, 'di ba, hindi naman excuse me. Hindi naman ito yung sample mo. So, ibig sabihin tawag diyan external solution or external standard. Kasi hindi ito yung sample na ina-analyze mo. So, that's external standard, okay? So, what you do with external standard calibration is that you establish the instrument calibration function. That means the response of your instrument with your external standards, no? And then later on, you compare your solution reading with the external standard, no? Calibration. So, yung process na kwento ko kanina, yun lang din yun. Okay? So, gagawin mo again, you have your external standard. Ito yon. You will do the regression. And then, you read your sample. Hanapin mo siya sa graph. No? Asan siya dyan? Sa line. Okay? So, that's the external standard calibration. And for external standard calibration, the line or the calibration curve, no? Yung calibration curve, yun yung line, can be described by the equation y equals mx plus b because that is linear, no? Okay, so using the equation y equals mx plus b, you can get the concentration that corresponds to the instrument response, that is the y-axis, okay? Okay, so when doing analysis, we also have to minimize some errors, no? So, paano yung mga errors, no? For example, ilog Pasig, ito na-encounter ko talaga to. Noong nag-analyze ako ng ilog Pasig kasama ko yung senior high ko noon eh. So, ginawa namin ng mga senior high ko, sinamahan ko sila sa ilog Pasig. Ito, manguha tayong tubig, no? So, after nun, naggawa kami ng chemical analysis and then nirun namin. Then, ang pangit ng result namin. As in, sobrang pangit ng result namin. Okay. So, paano mababawasan yung error mo doon? No? So, ginawa namin is that we do some cleanups, no? to make your sample cleaner, meaning ng cleaner, ibig sabihin, walang interference masyado. Okay? So, pwede mo tanggalin yung interferences. How? You do separations, no? Pwedeng i-filter out mo yung yung solution. Mamaya may plastic ba dyan sa sample nyo? Bumara pa yan sa instrument, no? Sisira yung instrument. So, ang gagawin mo, before you run your sample sa inyong analysis, filter mo yan. Pwede yon. So, that's one way of cleaning up your sample. Ano pa? Pwede mo pa yan i-concentrate using dialysis or solvent extraction, volatilization. So, ibig sabihin ng concentrate, binabawasan mo yung solvent. Pwede mo siya i-evaporate so that the solvent will be evaporated. Ang matitira na lang sa solution ay concentrated solutes. No? So, yun. So, yun yung mga process na pwede mo gawin to minimize the error. So, saturation method. That means yung mga interfering species, yung mga other chemical substances that is present in your solution, tatanggalin nyo sila. Okay? So, you will remove them. Okay? So, yung matrix modifier, that is the same concept with the saturation method. No? Okay, so yun yung mga nilalagay sa inyong solution to remove the other substances. Let's say drug testing. Ano yung mga kasama ng, let's say, methamphetamine hydrochloride? Ano yung kasama ng shabu sa inyong sample? Meron yung red blood cell, white blood cell, plasma, may mga leukocytes, erythrocytes pa yan, di ba? Etc. etc. Ang daming kasama. So, ang pwede nyo gawin is that you add the matrix modifier. So, ano yun? So, yung mga matrix modifier, yun yung magre-result na maghihiwala yung other substances with your desired substance. No? So, ang mangyari doon, pag nilagay mo yung matrix modifier, pwede mag-coagulate yung mga red blood cell, white blood cell, magsama-sama sila. Tapos yung clear part ng solution, yun yung i-analyze mo. Okay. Hindi yung buong red blood buong blood yung ilalagay mo dun sa analysis mo. Okay? Magugulo yung result mo pag ganun eh. So ano uli gagawin nyo? You add matrix modifier so that magse-separate yung solutions mo. Okay? And then yung clear part ng solution, yun yung i-analyze nyo. Okay? Sometimes you can also do dilution and matrix matching. So, ano yung dilution method? Okay, so kumbaga, gagawin mo sa dilution method is that you will add water until the interferents are no longer detected. No? Ano ba nangyayari kasi when we add water to our solution? The concentration decreases. Kapag ang interferents mo, yung mga nag-i-interfere na substance, masyadong nanggugulo sila sa reading, okay? So, ibig sabihin, mataas yung concentration nila. Ang pwede mo gawin is i-dilute mo. So, when you add water to your sample, the concentration will decrease, no? Hence, the panggugulo sa reading, yung interference, mababawasan, okay? So, that's dilution method. And then the next one is the matrix matching, So in matrix matching naman, you duplicate your you duplicate the interferences, from your sample, and then ima-minus mo yung reading doon sa inyong sample. So kumbaga, ito yung sample mo. Tas kunwari kasama doon sa reading yung interferences, Ang gagawin mo, you will duplicate the interferences concentration with another sample and then isusubtract mo yung readings nila so that ang matitira ay yung sa desired substance mo. Okay. So ganun. So ang daming process, So kumbaga, ang goal naman ng lahat ng iyan is to minimize your interferences, So how do we minimize the interferences again? So number one, you can do filtration, mechanical separation. Okay? So para mas malinis yung sample nyo. And then later on, if you have many interference, marami kayong panggulo sa readings, Kunwari, nagbasa ka ng analysis. Kunwari, graph yan, may nakita kang ganyan-ganyan. Hindi mo na mabasa kung alin dyan yung hinahanap mong molecule. Pwede mo tanggalin yung mga interferences. No? Pwede mo sila tanggalin. Paano? Ito yung mga methods na yun, yung kwento ko. So, pwedeng saturation method, you concentrate your solution so that the analyte, no, yung gusto mong substance yung mababasa. Pwedeng mag-add ka ng matrix modifier so that when you add that sa inyong solution, mawawala yung mga interferences. Pwedeng dilution if you do not want the concentration of your interference to be significant. Gusto mo maging undetectable yung interference mo, you add water lang. Matrix matching, kung ano yung concentration ng interference sa inyong sample, duplicate mo lang so that pwede mo sila i-subtract using calculate Excel. Pwede mo i-subtract yung mga reading, so you will just be left with your desired sums, with your desired substance na. So ganun. And then the other one is the other type of calibration is the internal standard methods. No? So anong ginagawa sa internal standard method? So internal standard method is that you add your standard. Again, yung standard, yun yung specified concentration. You add your standard with the solution. Once lang yan ginagawa. Okay. So kunwari, I have this blood sample. I will add known concentration of methamphetamine HCl. Lalagay ko dun sa blood sample. Okay. Then I will compare the two readings. No? Okay. So ganito yun. Kunwari, ganito yung sa drug testing. So kunwari, ito yung reference mo. Ito yung original methamphetamine HCl concentration. And then after nyan, ito yung sample with additional methamphetamine HCl. So actually, you can deduct this from this. And what's left is the concentration of your methamphetamine HCl. Okay? So, ganun lang ginagawa dito. So, babasahin mo muna yung inyong sample. And then later on, i-add mo yun sa inyong i-read nyo muna inyong internal standard pala. Sorry. So, you will read the internal standard and then later on, you will add it sa inyong sample. So, pagka-add mo yan sa sample mo, syempre mag-i-intensify yung peak, no? Kasi nadagdagan siya ng concentration, no? So, you can do that multiple times. Okay? So, pwede mo yung gawin multiple times and then after nun, you do regression analysis, no? Then, using that regression analysis, you can solve for the actual concentration of your solute sa inyong sa inyong sample. Okay? So, kumbaga, ang gagawin mo lang, again, is maglalagay ka ng standard sa inyong solution. Then, ima-minus mo lang kung ano yung sobrang reading. So, yung sobrang reading, yan yung hinahanap mong concentration ng, let's say, methamphetamine HCl. Okay? So, yun yung internal standard, no? So, again, ano yung difference niya with external standard? Sa external standard, may external solution ka. You will do your graph. Then, ano gagawin mo? So, dun sa graph na yon, i-run mo yung sample mo. And then, you check the response ng sample nyo with the graph. No? Iko-compare nyo yung response sa graph. So that's external standard. Ang internal standard naman, you will have your known sample, lalagay mo siya sa inyong sa inyong you have your known internal standard, ilalagay mo siya sa sample mo and then you will compare the reading. Kung ano yung excess, yun yung concentration ng hinahanap niya. Okay. Standard addition method is similar, no? With internal standard, no? So, ganun din. You have your known concentration, ilalagay mo siya sa inyong solution. Okay? So, depending on the intensity ng change ng response ng instrument, you can determine the concentration of your sample. So similar lang to actually. So internal standard and standard addition, they are similar. Gagawin mo lang, you have your known concentration, lalagay mo siya sa sample mo. Then depending on the reading, no, the changes sa reading, you can determine the concentration of your unknown. Okay? So yun. Ayun, malapit na tayo matapos. So again, similar lang to ha. So yan, they are similar. And lastly, punta tayo dito sa last part, no? Figures of merit, no? So, 'di ba may graph tayo? And we know that that graph must be linear, okay? However, in reality, yung graph na yon, that is not linear at all ranges, no? Ibig sabihin, it deviates from linearity at higher concentration or let's say lower concentration. So that is common, no? I do not have my kasi no, my data noong nag-aano chem ako nung college kasi nasa lumang laptop 'yun eh. Kaso nasira. So wala akong copy. Pero ang dami kong graph dati doon. For example, you are establishing the calibration function. Ibig sabihin external standard calibration to. 'Di ba mapapansin nyo, linear yan at first. However, let's say at higher concentration, the instrument is being um, oversaturated na siya, no? Overwhelmed na yung instrument nyo sa concentration so that hindi na gumaganda yung response ng instrument. Okay? So doon tayo nagkaka-deviation from linearity. Kapag yung instrument mo, hindi na niya nare-read ng maayos yung concentration mo. So what will happen kapag ganun yung nangyari? Instead of having a linear line, you will have a parabolic line. Okay? So nagiging parabolic curve yan. Or nagaano siya, hyperbola. So ganun. So parabolic, pag kinontinue mo yan, pwedeng mag U-shape, no? Hyperbola kapag it approaches to an asymptote, di ba? Geometry. So ganun. So nangyayari, again, when doing external standard calibration, pwedeng ang responses mo mag-plateau over time. Okay? So mag-plateau over higher concentration. So, ibig sabihin yan, your instrument is just limited to a certain range. No? So, ganun yun. Kasi kapag isasama mo pa yon, anong mangyari sa R-square nyo? Bababa. Papangit yung linearity. So, in order for you to do accurate analysis, you have to remove those parts, no? Tatanggalin mo yung mga part na pangit na yung reading. Okay? So that means your instrument is not able to measure all of the concentration range. Hindi niya babasahin lahat ng concentration range. Only those that will give us the best fit of line, no? Yun yung magbibigay sa atin ng line, no? Hindi yung parabola. So that means hindi mo isasama to, only the linear part will be considered. And kung ano yung concentrations ng linear part, we call that the dynamic range, no? Okay. So the dynamic range is the concentration, let's say, no, that is the concentration at which your instrument response is linear. Kapag tumaas na kasi yung concentration, what happens is that it it plateaus, no? Ibig sabihin ng plateau, nagfa-flat na yan. Okay? Naging hyperbolic na siya. So ayaw natin nun. Gusto natin linear lang. Okay? So yan. What else? Ano pa yung mga terms dito sa Anachem? So other than the the dynamic range, we also have the calibration sensitivity. So when we say the calibration sensitivity naman, that is actually the slope, no? The slope of your curve, no? Suppose we have 3 curves here. One is this, the other is this, the other is ito. out of these three curves, no? Para tayo nagjo-geometry, no? Out of these three curves, which of the three is the most sensitive? Ito. Itong nasa gitna. Ito yung most sensitive. Bakit? No? Kasi the slope is too high. When you say the slope is too high, onting kibot mo lang sa x-axis mo, yung y-axis, ang taas na ng pinagbago. Okay? So, onting change lang sa concentration, the response sa y-axis is masyadong mataas, no? So, yan yung most sensitive na calibration curve, no? So, that means onti lang yung concentration range na kaya niya i-read, no? And then the least sensitive would be this one. Okay, so paano yan naging least sensitive? Because ang laki na ng concentration difference, yet your line, your calibration curve, yung inyong graph, no, hindi siya ganun nagbabago yung y-axis, no. And that is not good when doing chemical analysis, no. Kasi mamaya mag-overlap yung readings, mali pa yung mabigay na result, no. So, ganun. So, yung most sensitive, hindi rin siya always good, no. Bakit? Kasi mamaya lumagpas pa yung result, yung reading mo sa sa kaya ng graph, no. So, that means pangit to, no. Kasi onti lang yung range na onti lang yung range na kaya niya ma-read, no. Kasi nga the slope is too high. So that means you are limited with a few concentrations lang. Ito yung pwede sa ultra micro analysis, no. Yung mataas yung sensitivity. Pero kapag yung normal analysis, hindi siya good. Kasi masyadong onti lang yung range na kaya niya basahin. Yung least sensitive naman, hindi rin to good at all. No, this is not good at all kasi baka hindi mo na ma-distinguish yung concentrations, no. Hindi mo na siya ma-read masyado ng maayos because the instrument response is overlapping. So, yun yung least sensitive. The good one is ito. Yung ganyan yung itsura ng graph. Okay, so yung ganyang itsura ng graph, that is a good calibration curve. Sir, paano namin makikita? Ganito lang gagawin nyo. Pag nag-Excel kayo in the future, makikita nyo naman yung curve eh. If ganyan, ganito, or ganyan. Okay. So, better is yung ganito. Yung hindi siya masyadong greater than 45 degree angle. No? So, around 45 degrees yung inyong curve. No? So, yan. So, ano na lang yan? Kanya-kanyang preference. No? Kung gusto mo ganyan or medyo mababa, pero wag lang super taas or wag lang super baba. No? Pangit na kasi yung dalawang yan. Although itong most sensitive, this is good for ultra micro. Pero again, hanggang dun lang siya. That's not good for other types of analysis. No? So, hindi siya pwedeng hindi siya pwede sa trace, pwedeng hindi siya pwede sa minor or major analysis. No? Okay. Okay, so last one, the detection limit. No? So, di ba, papansin mo yung, itong line na to. So, usually, di ba, ito yung dynamic range natin. Ito yung pwede mo malaman yung accurate concentrations, di ba? Meron yung tinatawag na detection limit. No? So, the detection limit is the lowest concentration that can be read by your instrument. Okay? Sometimes kasi sa super onti na ng concentration ng inyong constituent, ng inyong molecule sa inyong sample, pwedeng zero na yung ibigay ng instrument. No? Sa super onti niya, hindi na niya mabasa yon, nagsi-zero na lang yon. Okay? So that means may limit yung lower end ng graph natin. So so when doing analysis, you do not solve for anything lower than the detection limit. Sir, paano namin malalaman yung detection limit? Kukunin mo lang yung standard deviation. Kung ano yung concentration ng standard deviation, yun yung detection limit. Hanggang dun lang. Okay. So anything lower than the standard deviation is noise, no? So hindi na siya mababasa ng maayos. So that's the detection limit. Okay, so yun lang. The linear dynamic range, that is the range from your detection limit, from your S standard deviation, up to the last point na linear yung graph. Okay, so kapag nag-hyperbolic na yan, burahin mo na yan. Okay, for example, ito. Nag-hyperbolic na yan. Tanggalin mo na yung part na yan. Okay, so only from detection limit up to the highest concentration, yun lang yung reading mo. Okay, you will learn more of this when you are in your biostats, no? Kasi our time dito sa Anakem, it seems na maluwag pa tayo. Sa ngayon, maluwag pa yung schedule natin. Pero later on, makakram up na tayo, no, ng ideas. Starting next week yon. Chapter 3 na tayo next week eh. Okay? So, we're done with chapter 2 already. So, kung mapapansin nyo, parang more on kwento lang talaga siya. Yes, kwento lang talaga meron dito. Yung in-depth details dito, this will be discussed sa inyong biostatistics, no? Last time kasi, nung trinay namin isama to sa mismong Anakem's discussion, ang nangyari sa students ay mas lalo silang naguluhan, no? Kasi magso-solve ka pa ng regression, no? So, yun, masyado na silang occupied, no? Masyado na silang concentrated na yung isip nila masyado with all the lesson stuff. So, ginawa na lang namin in consideration sa students. Hindi na namin siya undi ginawa ngayon, no? So, kasi marami pang statistics that will be involved dito, no? Regression, alam niyo pa ba yung formula nun, no? So, alam ko hindi na, no? So, yung mga ganung bagay, they will be discussed na lang sa inyong biostatistics, no? Which is, I don't know, next year or next sem. So, ganun. So, we're actually done now. So, let's summarize the entire lesson na lang para ma-recall ninyo yung mga pinagsasabi ko kanina. Okay, so again, when doing analysis, you do not get all the all the amounts of your matter, no? Kunwari, nag-a-analyze ka ng ilog, di mo dadalhin yung buong ilog sa laboratory. You will only get samples. Again, sample is a small portion of your population. Okay? Depending on the amount of your sample, you can do different types of analysis. You have macro, semi-micro, micro, and ultra micro analysis. Depende sa amount ng matter, no? Because yun nga, depende sa amount ng matter, there is a corresponding methods for that, no? Meron siyang corresponding procedure. Hindi mo pwede gamitin yung procedure ng ultra micro sa macro. Hindi pwede yon. Mamamali yung result mo. Okay? So you have to identify first how much sample do I have here. Then after that, you check our cookbook, no? That is the book na may na may steps kung paano magawa ng analysis, no? So every type of analysis specific yan for different sample sizes, no? Okay, so kapag super onti yung sample mo, hindi mo gagawin yung macro analysis methods. Hindi mo gagawin yun. Mauubos yung sample mo. Okay, so for each sample size, there is a corresponding method. Also, depending on the amount of your the amount of your analyte. Ano pala yung analyte, sir? Yung analyte yung solutes sa inyong sample. So, instead of sabihin ko na lang na solutes sa sample nyo, I will call them analyte. Okay? So, ganun. So, yung mga analytes nyo, yung solutes sa sa sample nyo or sa solution nyo, depende sa concentration nila, you can classify them as major, minor, trace, or ultra trace constituents na. Okay. So, they are actually similar with this one. Okay. Itong nandito. So, yan. And again, dun sa kinuha niyong sample, hindi lahat yon gagamitin mo. For example, again, yung 1 litrong tubig na kinuha namin sa Ilog Pasig last year, hindi lahat yon gagamitin. No? Only a few portions of that. No? We call that the representative fraction of your sample. Okay? And assuming that that is a solution, kung anong concentration sa representative, that is the concentration for your sample and the entire population. Ayun. So, kung mapapansin nyo, yung inyong sample size that is constantly being reduced to a workable amount. No? So, syempre, yung 1 liter, hindi mo yan ipapasak sa instrument. No? Same with blood, hindi mo ipapasak yung buong blood vial mo sa chromatography. Masisira yon. 1,000,000 yung greater than 1,000,000 pa naman yung instrument na yun. So, ayaw mo masira yon. Okay, so you will only get few amounts of your sample. Okay, so onti-onti lang para workable sa laboratory. So after you have your sample, then you should have your standard and your calibration curve. So ano yung meron dito? So, 'di ba, babasahin mo na yung sample mo. So when you're reading your sample, you have to compare it with a standard, no? What is a standard? That is a solution of known concentration. Standard, known concentration. Okay. So you will compare the instrument reading ng sample nyo with your standard calibration. So, depende kung ano yung instrument response sa sample nyo, then there is a corresponding concentration for each. No? This process is called external standard calibration. Okay, so ano ginagawa sa external standard calibration? You prepare standard solutions, solution of known concentration, you read it sa instrument, you get the linear curve, and then you compare your sample result to your curve. That's external standard calibration. The calibration curve this for this method is linear, so that means it follows the equation y equals mx plus b. Okay, and doing analysis, we also have to minimize errors. So how do we minimize error? We can do separations. Pwede mo i-filter yung sample mo so that other particles will not interfere with your sample. Pwede naman yung saturation or matrix modification so that mawala yung mga matrix. Yung matrix yun yung entire solution mo. Okay. So, dun sa matrix, dalawa kasama dyan, yung analyte, pati yung interferences. No? So, gagawin mo, sa matrix modification, you will add certain substances to your sample so that the interferences will clump together. No? So, magsa-separate yung mga interferences. The saturation method naman, what you are doing here is that you are concentrating your analyte. No? Kina-concentrate mo yung analyte so that they will be readable sa instrument. No? Mababasa na siya ng instrument. Dilution and matchmaking, ito naman, you change the concentration of your interferences. Okay, so you change the concentration of your interferences so that yung matitirang reading ay yung sa inyong analyte or yung sa inyong desired molecule or ions. Other types of standard calibration ay internal standard method wherein you have your internal standard. You will compare it with your analyte. No? So, depende sa differences ng kanilang measurements, you can get the concentration. Okay. Ito naman ay standard addition method. So, you have your internal standard. Ilalagay mo siya sa inyong solution. Okay. And then, depending on the changes sa reading, there is a corresponding concentration for the unknown. Okay, so, similar concept with internal standard. And then lastly, ito naman yung pag-interpret ng calibration curve. Again, so not always linear yan. It will come to a point where it will approach the asymptote. No? Ibig sabihin, magpa-flat yan, magpa-plateau yan. Okay. So, the point where the graph is linear, we call that the linear dynamic range. And that is the only range of concentration that is applicable to your analysis. Anything beyond that, hindi na pwede. Okay? And ano pa? Yung ating dynamic range, meron din siyang tinatawag na detection limit. No? So the detection limit is the range of the concentration where hindi hindi significant yung readings mo doon. Ibig sabihin, noise sila. Ibig sabihin, hindi sila maganda gamitin for analysis. No? Okay, so ibig sabihin itong portion na to, kapag may nakuha kang reading dyan, medyo kaduda-duda yon. Okay? Because pasok siya sa range ng noise. Ano yung noise? Yun yung standard deviation. So pagpasok siya dun sa standard deviation ditong part na to, so pangit yung reading mo doon. Hindi mo siya masyadong pagkakatiwalaan. Saan mas reliable yung result? Dito sa linear dynamic range. Okay. So sir, paano uli nalalaman detection limit? Kunin mo lang yung standard deviation ng curve mo na to. May equation for that. Masyadong mahaba yung equation kaya kinakalky ko na lang. So pwede yun i-calcu. So, pag nakuha mo yung standard deviation ng line na to, hanapin mo yun sa x, yun yung detection limit. So, it means anything below that, hindi reliable yung reading. Pero anything above that, until the end of your linear dynamic range, dun reliable yung reading. Okay? So, yun. And then, also, depending on the slope of your curve, you can have different sensitivities of your calibration. So, pwedeng kapag super steep yung slope, ibig sabihin masyadong positive yung slope, approaching to 1. Okay? So, if your slope is approaching to 1, then we can tell that that is a very sensitive calibration curve. Okay? So, that is good for ultra-trace analysis. Pwede rin siya sa trace, no? Pero not always. Pero this will not be applicable for macro and micro analysis, no? So, hindi pwede yun sa mga ganun. Ito naman yung usual. So, at least your slope should be around 45-degree angle. Kayo na bahala infer kung okay na yan. Basta around 45-degree angle, pwede na yan. Although may equations for that, no? Sa biostats na lang. Masyadong mahaba pa yung equation part. Ito naman, if your instrument is least sensitive, that means ang laki ng concentration difference pero yung instrument response mo super onti lang. So, pangit yon at all. Okay? So, hindi mo siya magagamit masyado. So, you want something that is in between sensitive and most sensitive. No? So, somewhere there. Pero anything na least sensitive, not so good. Because pwede mag-overlap yung readings ng inyong instrument. Okay? And that ends our discussion for today. Okay? So, sir, paano yung quiz mo dito? Basically, kung ano yung mga info lang dito, yan na yung nasa quiz na. So, I will instruct you kapag magre-review ka na nito. Basahin nyo na lang uli. Okay? So, kung ano yung mga nandyan sa slides, yun yung most likely lalabas sa quiz na. Kasi wala tong calculation na. So, more on chika-chika lang to. Okay? So, yan. So, this quiz will be the easiest quiz sa lahat ng quiz na iti-take nyo. Okay? Kasi yung quiz 1 ninyo, which you will take starting Feb 4 until Feb 7, yung quiz 1 ninyo medyo mahirap pa yon kasi may calculation. Ito lang yung chapter dito na wala masyadong calculation. I mean, wala talagang calculation. Okay? So, yan. Pag magre-review kayo neto, ang tip ko na lang is basahin nyo na lang ulit. Okay? So, kung ano yung nandito, yun din yung lalabas most likely. So, yun. So, anyway, that's all for today. Do you have any questions or okay na tayo? Antok pa ba kayo? Okay, so I think we're good for today, no? Okay, so that means I'll see you again next week, no? So, sir, kailan mo i-open yung quiz dyan? Yung quiz 2, that will be open next week na lang. Okay, so next week, Thursday to Sunday pa rin yung ganap. Mag-prepare muna kayo sa quiz 1. Again, quiz 1, ito na yon. Ito yung coverage. Kung ano yung na-discuss natin, yun din yun. Okay? Pero this time, 90 minutes muna. Okay? I want you to adjust kasi try nyo habang nagsisolve kayo. Huwag nyo sagarin na 90 minutes. Try nyo at least 60 minutes below. Pag nakaya nyo na yon, ibig sabihin, kayang-kaya nyo na yung mga future quizzes natin. So, magiging 60 minutes below na yan, starting quiz 2 and beyond na. So, ganun. So, mag-practice kayo na below 90 minutes, especially kapag calculation. So, yan. Kailan open yung quiz? It will be available starting Feb 4, 8 a.m. Ayoko mag-take kayo na madaling araw. Yung iba ganun ginagawa. Matulog naman kayo. Okay, so that will be available Thursday 8 a.m. until Sunday midnight, no? Feb 7 midnight. Okay. Yan. So that's around 3 days availability. Okay. So yun lang. Again, quiz 2 will be open next week, no? Next week ko na lang siya buksan in line with our discussion sa chapter 3. Ano na ba tayo, sir, sa chapter 3? Ang favorite topic ko. So, pag sinabi kong favorite topic ko, may solving. Okay. So, equilibrium na tayo next week. Okay. So, that is around 3 weeks discussion. Okay. Medyo matagal yung discussion natin doon. So, sa ngayon, chill-chill lang, pero in the future, hindi na. Okay. So, we will do chemical equilibrium na. Okay. So, yan. So, anyway, so yun lang. And so, good luck. Good luck starting chapter 3. Ngayon, madali pa lang eh. Okay. So, that's all for today. I'll see you again next week na lang. No? So, if you have any questions, PM nyo na lang ako. If you happen to be unable to take the quiz on time, hindi kayo makapag-quiz agad kasi may sakit kayo. Just tell me. Okay? So, ganun lang. Okay, so that's all for today. I will upload this class recording sa YouTube para mapanood nyo na lang ulit. Okay. Excuse me. So, yun. That's all for today and I'll see you again next week. Ingat po. Bye-bye.